Thanks for looking at the third part of this video series. In this part, we'll actually take care of the rest of the parameters, make this a fully parametric model, show you how we do that with separate parts and how they're fitting together, how we access the spreadsheet to make sure that we have the right clearance the whole way through, no matter what size we make the box. So hopefully you'll enjoy it. If you do, give this a thumbs up and make sure, if you haven't already done so, watch part 1 and part 2 first. Otherwise this part 3 won't make sense. So it's a good idea to make sure you watch them in order, and then you'll see how the whole thing works as one. I did originally create this as one video, but obviously it was too long, so I split it into 3. So hopefully you enjoy it. Let me know. Leave me a comment, thumbs up. If you haven't already, subscribe to the channel. I'd appreciate it. I appreciate all your support, and thanks again. Okay, so welcome back. And what I've done is I've created parameters that describe where this cutout is and where these lugs are. Here, these lugs, and these standoffs. And I intentionally left the clearance between the standoff and the box so that it wouldn't bind as it goes on, and allows for any distortion or anything we have. We don't want it to be a perfect fit because the lid would be tight. And so what I've done is, now that lid has a gap there and air can come up there and flow through. I'm not going to put a fan in it because I don't think it needs that. I just don't want it to overheat. It doesn't produce a lot of heat. So a couple of things on my parameters. So as I said before, it's really important to keep your directions organized. So I've always the shorter one in this case, or if I turn this box, let's put it back to the top view and get it that way around. So if I have it this way around, then this is my width, this is my length. And it doesn't matter if something is longer or wider, the directions are going to stay the same. The reason for that is you want to make sure that as you're naming things, that you can understand which one did I make the width, which one did I make the length, and whereabouts did I dimension it from. So right now I have it all dimensioned the same way with the same width, length, names based on whichever part it is. So right now the box lid and the box itself and the PCB all have the same length and width directions. Then the other thing that I think is important when we're doing this is that you try not to use arbitrary numbers. And I have done that, and I'm going to solve it right now, but I wanted to talk to you about it first. So for these standoffs, I have, go to the box, standoff length, you'll see that number is just 8. And what that means is I know where this starts. That's my box standoff width, and my my center width. My box lid standoff center width is from the center out to there. And so I know where that starts, but then I need to know how far should I go with this. Well, this is a function of how thick is this wall and how wide is this gap. So I think what I'm going to do is I'm going to create some reference information, and one of them is going to be the gap between the body and the lid. So the lower box and the lid. So I'm now going to put those in a separate list here, and I'm just going to say, I'm going to call that gap, lower body, lower, let me just, I just want to keep the name in the same, lower box. So I'm going to keep gap lower box, box lid. I would like to put a dash in there, but apparently that doesn't work with the aliasing, so we're not going to do that. So that gap there I know is 5 at the moment, and it's an arbitrary amount. That one is one that I just created to be 5. But by listing it here, I can change it if I want to change it. So for now, I'm going to put it in as 5. And I'm going to just alias that. So let me just do that real quick. Just using that easy alias again, just to create that. So now I have that 5, and then this is going to be a function of that gap and this wall thickness. Now, I know that wall thickness is the same as the wall thickness that I have here. The lower box wall thickness is 5. So maybe what I'm going to do is I'm going to put in a general one here that says wall thickness. And I'm going to make that equal to my lower box wall thickness. So they're going to remain the same. I'm just going to alias that one quick. So now I know this should be this gap and this thickness, and that would push it 1 millimeter out of the end. So I want to reference that clearance there. So I'm going to call this clearance. Actually, what I might do is I'm going to do it this way. I'm going to call it box lid standout clearance. And that's 1 millimeter. I'm just going to hit that one. Make that an alias. And then I'm going to go up to here where I have my box lid standoff center width. And I'm going to make that one the box lid standoff clearance. Standout should be standoff. I'm going to change that before I make a mess of it. Let's just fix that. I just don't want to call it something else and then cause it to be an issue. There we go. I'm just going to redo my alias just to make sure the alias is correct. So standoff clearance, perfect. So then I'm going to go back up here to my box lid standoff center width, and I'm going to make that box lid standoff clearance. And then this one. Oh. That's weird. And this one also is going to be box lid standoff clearance. I don't know why when I first hit that it comes up with something weird there, but I think it's just a artifact. I'm not going to worry about that. So now I know this clearance is what's being used here. So then I can make this length it's box lid length, or box lid standoff length is going to be my wall thickness plus my lower box minus my standoff clearance. I'm going to make it minus my standoff clearance times 2. That'll leave me 1 millimeter inside here. So this one is going to be equal to gap lower box lid plus wall thickness It's weird. It seems to pick up the wrong thing. Minus. And that one is called the box lid standoff clearance times 2. And there we have it. So now that's calculated rather than just an arbitrary number. And it's based on my clearances. So that's basically how I like to do it. I don't want to have arbitrary numbers in this. I'm going to go through my spreadsheet once more and just check. And if I find any, I'm going to come back and show you how I fix them. Okay, so finally we have everything parametric. The components themselves don't really move around the board, but I can change the board size and it will change the size of the enclosure. I don't expect my enclosure to change that much, but I'm going to measure my centers and my board width and board length, and if it's minor modifications, everything will just modify automatically. So let's start out by turning on, this is the PCB obviously, we're going to turn on the lower box, and I'm going to assign the lower box a random color. Just do it to that body. There we go. So now the box has a color as well as the PCB, and then you'll be able to see the lid on top of that. So first things first, I have a set amount of clearance from the PCB to the inside of the box, and I gave that a dimension. Lower box distance to outside of 30. I can modify that independently, and I did that on purpose because I wanted to be able to modify that clearance around there, because depending on what fits in there, I might want to have a bigger space. I made it equal all around because honestly the size of the box is not important. The outside size is not important for me. It's going to just sit on top of something. It doesn't slide into a space or anything like that. So the other thing that is set up parametrically is where this component lies is where this cutout is going to lie, because the wires go out of the front here and go through this cutout, and the same on this end, they go out here and come out through this cutout. The wires from this component go out through the roof, and the same with this component, they go out through the top. So there's not enough space, or you don't really want to bend the wires over from there at 90 degrees. That would probably be a bad solution. So I'm just going to go straight up through the lid. And my lid, I'm going to drop that on. There's my lid. And I'll give the lid its own color. There we go. So now we have the lid. And the lid is intentionally overlapping. And there's the cutouts for those connectors. If we look from the top view, you'll see I made them the same size as those connectors because actually the wires sit inside of those connectors, of course, because they plug in with another connector. So that's plenty of space there to get the wires out. And then the piece that I wanted to do was to create these standoffs so that the lid is a bit wider than the box, and that standoff prevents it from jiggling around too much. And then these little lugs hold the lid up from the box itself. And that way I've got airflow that goes in through here and go the whole way down. So parametrically, of course, I can change the size of the box. And I do that by changing the PCB. The PCB is the driver for all of this. So if we look here, we can change the width. Let's make it something arbitrary. This is the width of the PCB we're changing. Let's just pop that over there so you can see. So that's my PCB width, my PCB length. And you can see everything moves and stays on point. And this is one thing I don't like there. It looks like my piece here is just sticking through too far, so I'm just going to change that length. That one would be in our box lid standoff length. And we're going to make that the clearance times 2. And that will just get rid of that. It just moves that edge back inside there. So I want to make sure that is correct. And yeah, everything looks good. Bring those sizes back down now. Back down to 106 width. And we'll go to 157 length, which is about where mine should be. And so you can see I have the lid there. Now the one thing I did do as well is I made it so I can change the overhang of that lid. So if I want that lid to overhang, let's say box lid overhang is set 8 right now. If I wanted that to be 12, for instance, I can just adjust that and it'll make the box lid overhang and it'll fix these lugs and everything so that it fits correctly still on the lower box. And then what I'm going to do is I'm actually going to move that to somewhere 9. I think is better. Yep. So maybe we'll go with that. That way I can change the overhang, the amount that it overhangs there if I want to. And everything else is parametric. And I think what I'll do for my final piece is I'm just going to add some radii. So before I do that, I'm going to do a save, because whenever you add radii or you do something that could potentially blow up your model, it's a good idea to do a save. So I'm going to press Shift and just select these. Make sure I've got the active body. It doesn't seem to want to hold. Press Control and hold them. Seems to work. There we go. And I'm just gonna put them on this way. This way. Here. So that's all the edges around there. And I'm just going to apply a radius. And I'm going to make that radius 2 millimeters, so it shows up. And I'm going to do the same thing for the base. all those edges. Give those a radius. Gotta make my body active. So let's redo. Sometimes if you're switching between bodies or you've got multiple bodies in one model, it's easy to get the wrong piece or not make a body active. And of course, FreeCAD will yell at you and tell you what you did wrong. It's not really wrong, it's just not done. And there we go. And we're going to make that 2 mil as well. And then we have the radii. And although it looks a little strange, I think that's going to work quite well. That'll keep everything mostly dust free and it'll allow the air to circulate. And I think that'll work good for me. So I may print it out in the future. I'll show it to you if I do. And I'll just walk you through quickly through this spreadsheet because this video is going to be long. So all I did is I created all the dimensions for my PCB. Most of those are not calculated. I did calculate the whole center widths so that it kept the holes out in the corners when I changed the size of the PCB. I thought that made sense. So all of the PCB parts are set, and then everything else is calculated off that. The ones in red are my calculated ones, and the ones in black are ones that I can change. So I want to be able to change that distance to the outside, so I left that. It's not a calculated amount, it's however much I want it to be. And then I calculated everything else from that PCB and basically allowed some modifications like the overhang I can modify. But you'll notice I also split up my parameters, so these are all in the lower box part. These are all in the box lid. And then these are some general ones that you can access. And of course you can access all the calculations are done in the spreadsheet and then applied as dimensions. Now there are one or two pieces that are applied to things like offsets. So if you have an offset for a sketch, for instance, there's one. So you can see I had set this up to the spreadsheet lower box height. So anywhere where there's offsets for pads or offsets for sketches or depths for pads that are calculable, I used the spreadsheet to set those dimensions. So those are parametric too. So for the most part, this box is all parametric and will always fit the way I want it to fit and should work nicely for my electronics. So that's basically it for this one. I could go into more detail on the calculations, but I don't think I'm going to because it gets a bit complicated. You know, just knowing what relation what has to what, you know, what things are related to each other. So for instance, if I look at this lug here, the position of that lug is the width of this box minus half the 1.5 of the diameter of that lug. So, you know, these are all things that you can pick arbitrarily. You can, you know, you come up with your calculations, how they're going to work. All you need to do is to make it so that your calculations are always driven by a certain dimension. And in my case, the PCB is the driver. So if I change the length and width of the PCB, my box changes around it. And the way my lid fits is always set and changes around the size of the PCB or the size of the box. And so you can build a complete parametric model as long as you decide where your drivers are and you lay things out sensibly and you try and keep the width and length organized so that when you're coming to add those dimensions, you can pick them off the spreadsheet and they make sense to you. So that's an important an important part to remember is you want to make sure that they make sense to you, because if they don't, you'll get lost very quickly. So change that to 3. See how that looks. I think it actually looks better with a 3mm fillet, so I think I'm going to change that one as well. And of course I could put my, let's give you an idea for these general ones. If I come down to my spreadsheet here and I say cosmetic radius, and I call that 3 for now. Gonna hit that guy, spreadsheet, link that one. Now I'll go into my radius here, go in here, click on here, say spreadsheet, cosmetic radius. Say okay. I'm going to go down to this one and say spreadsheet cosmetic radius. So now they're both set up here. So if I wanted to change the radius now, I can just make it a little bit bigger. Doesn't look bad. 4, what 4 would look like. So that changes it to 4. Could even go to 5, I guess. Just for grins and giggles. Yeah, it might look better with the bigger one. So yeah, let's go with the bigger radius. And leave it at that. So if you have any questions, comments, feel free to leave me a comment, reach out to me on email, or shoot me a message some other way. If you're a patron, you can shoot me a message in Patreon. If you're a member, you can leave a comment on in the membership forum there. And I also created a new community called CAD Beginners. And what I've been doing is I've been collecting posts that I think are interesting and cross-posting them here, and creating some of my own posts as well. The weather and just some general information, just bringing it all together. I'm more than happy if you want to join in there and join that subreddit. It's called CAD Beginners. And if you join the subreddit, that's another good place for us to communicate. So, again, thanks for your support. I appreciate it. We did just turn 11,000 subscribers this week. So very pleased about that. And thanks for watching the videos. And if you are interested in seeing more, feel free to subscribe. We could always do with more subscribers. You can join our Patreon, or you can become a member of the channel. And the links are below. Thanks again. See you in the next one.